Hello, this is Dr. Tina Cannon from ChattState, and in this session we're going to learn how to work with linear regression using our TI calculator. What we want to do is look at a homework problem that's located in Unit 2, Section 2.2. And this problem comes from some information that's in the textbook, and this is data about bears. The first list that we have gives us the chest size of bears, and the next list gives us the weight of the bears. And what we want to know is there a linear correlation between these two items? If there's a linear correlation between these two, then we will be able to make a prediction. If we're given the chest size of any bear, then we should be able to predict an approximate weight for the bear. That's only if there is a linear correlation. So what we want to do is first calculate a regression equation using our calculator. So I'm going to pull up the calculator. And the first thing you want to do is place the values in List 1 and List 2. So we'll go to Stat and push Enter. And what we want to do is type the values into the calculator. So currently I've already typed the values. So you can pause this video and type in the values that are given for us. Now, to find do linear correlation, or to find our regression equation, what we need to do is look at under statistics. We want to look to see if there is a linear correlation. So I'm first going to push Stat, move over to Calculate, and if you notice the form that our equation is in, notice the X is on the second number. So what we want to do is we do not want to use 4 right now. We will go down to number 8, which says linear regression A plus BX. And what we want to do is select number 8 and push Enter. And then you have to make sure you push Enter again, and it should give you the linear correlation, or the linear equation, I'm sorry. So in this particular problem, notice it says they want us to round to 2 decimal places as needed. So our first value that we're going to have will be negative 99.36. And the next one that we will have will be 12.05. So let's type in the values and see if this is correct. And the next one was 12.05, and we want to check our answer, and notice it tells us that we're correct. Now what happens is there is another step in this. To be able to make a prediction, we've got to determine if this is a significant linear correlation, which, if you notice on my calculator, currently the R value is not located on here. So what I need to do is I need to do this one time on my calculator. Now, your calculator may have shown an A, a B, an R square, and an R. If it did, that's perfect. What happens is right now, my calculator does not have the R value on there, the correlation coefficient. So to turn this on, if your calculator does not show an R and an R square like this one does not, you're going to push second and 0 for catalog. And what we're wanting to do is turn diagnostics on. If you notice at the top right hand corner, we are in the alpha mode, which means the alphabet, and we're wanting to turn diagnostics on. So I'm going to select the key for D, and I'm going to scroll down to diagnostics on. I'm going to push Enter twice. Be sure to push it twice and it'll say done. Now, when I go back to Stat and move to Calculate, where it says, remember number 8 was our linear regression that we used, and I push Enter again, now it gives us everything that we need to do. We only have to do this one time to turn our calculator on, the diagnostics on. From now on it should be here. If you change batteries, you may have to do this again. Now, the reason we want this, we have to determine if our equation is, if the data give us a significant linear correlation. And if it did, then we can use our equation to make a prediction. If it didn't, then we have to take the mean of our y values. Now the first list will be x and the second one's y. If there's not a significant linear correlation, then you actually have to find the mean of y and use that as your prediction. So let's go to our course and let's pull up our formula sheet. Underneath where it says Student Resources, go down to where it says Formulas and Tables, and you will use this to determine if there's a significant linear correlation. Now, currently I'm on table A6. That's where you want to be. Notice this is the critical values of the Pearson correlation coefficient R. If I call my calculator back up, we can see that our R value was 0.983. Now if we look at our problem, notice it does not tell us which alpha to use. If it does not tell you an alpha to use, what we want to do is use 0.05. If it tells you, then sometimes it'll tell you specific alpha to use. Now also we have to look to see how many pairs of points we had. That's going to be the n in this table. So go back to our problem. Notice there's 1, 2, 3, 4, 5, 6. So our n will be 6. If I can find it, n is 6. Notice that we're going to use alpha as 0.05 and we have a critical value of 0.811. Now, here's how you determine. If your R that you calculated on your calculator is greater than the critical value, that means there is a significant linear correlation. If R is not greater, then there's not a significant linear correlation. Now, you have to remember, if you come up with a negative R, you have to take the absolute value of it and use that. But right now, our R value, let's see what we have. Our R value is 0.983. That is greater than 0.811. So that means there's a significant linear correlation, which means we can actually use our equation that we come up with. Let me go back to our equation. We can use this to make a prediction. Now, notice in our problem, the data show the chest size and weight of several bears. Find the regression equation, which we did, letting the first value be the independent variable x. Then find the best predicted weight of a bear with a chest size of 62. So what we're going to do is we're going to take our calculator and we're going to put 62 in for x and work it, because we can use this equation because there was a significant linear correlation. So let me pull this up. And let's see. What we want to do is type in negative 99.36 plus 12.05 times 62, because that's the chest size. Now what we're doing is predicting how much this bear is going to weigh. So we predict that this is the weight of the bear. Notice it says to round to 1 decimal place, so we will have 647.7. So that's how much we predict that the bear will weigh based on previous data. 7.7. And we're going to check our answer. Okay, and so our answer was correct. This gives you an example of when there is a significant linear correlation. I'm going to move through the homework and see if I can find one. Let's see, I'm not sure. As you go along, you will have to actually go through and work each problem and take your R value and compare it to your critical value. And like I said before, there's some different problems in here that you'll have to go through and work. If there is one that the R is less than the critical value, what would happen is you would have to find the mean. I'm going to go back to the problem we just did. I'm going to show you how, if you needed to find the mean, how you can use your calculator to find the mean. Remember, we're trying to find the mean of the y values. So I'm just going to show you that because sometimes they ask you to make a prediction and you'll have to use the mean of y. So let's push stat, move over to calculate, and we're going to push enter. And remember, our y values are in our second list, so I can push second and the number 2. for list 2 and push enter, and notice there would be the mean. So if there was not a significant linear correlation, then my best predictive value would have been 565.2. Also, if you push stat, move over to calculate, notice the 2 variable statistics. We have 2 variables in our calculator. You could also use this one, number 2, and push enter. Now notice the first one deals with x. If you notice there is an arrow, if you scroll down, there's the y values. So notice there's the mean of y. If there had not been a significant linear correlation, I would not have been able to use the equation, and that would have been the mean of y would be the closest value that I could use. So this is an example of how to use linear correlation to make predictions.